In this video, we're going to look at how we can solve quadratic equations by factoring. So we're going to take that skill of factoring that we've learned last week, and we're going to apply it to actually solving equations. In the first equation here, we have x squared plus 3x minus 40 equals 0. So the first thing we want to do in every one of these problems, as the notes say above, is we're going to look for a greatest common factor. Now, there isn't a greatest common factor here, so what we're going to then do is think, okay, is this a difference of squares problem? It is not. So then what we have to do is look and see, okay, is it a sum and product problem or a slide and divide problem? So remember, sum and product is when a value is 1, slide and divide is when it's greater than 1. In this case, our a value is 1, so this is just a straight up sum and product problem. We have to sum to get 3 and a product of negative 40. So right off the bat, the way to get negative 40 to me is 5 and 8, but 1 has to be negative. So I'm going to make the 5 negative so that I can get a positive 3 when I add them together. So those are my two factors, x minus 5 and x plus 8. Now that's the factoring that we're used to, but now we have this equals 0 part, so we have to bring that down. And once we get that equals 0, what that does is that allows us to use something called the zero product property. And what the zero product property says is, if this thing's 0 and I multiply it by x plus 8, I'll get 0. But it also says, if this thing is 0 and I multiply it by x minus 5, I'll still get 0. So basically, if either one of these things equals 0, then the whole solution is 0. So all we have to do is solve these two individual equations. So we have x minus 5 equals 0. If we add 5 to both sides, we get x is equal to 5. On this one, if we subtract 8 from both sides, we get x is equal to negative 8. So you have two solutions for this problem, negative 8 and 5. Now you don't have to write it like this. I just think it's a nice, neat way to write a final solution. Alright, let's look at example B. Example B is x squared minus 9x equals 0. So again, always look for a GCF first. And in this one, we do have a GCF of x. So we factor out that x, and then we write what's left. X squared divided by that x is x. Negative 9x divided by x is just negative 9. And then we're going to bring down our equal 0. From here, notice how we don't have any x squareds. We just have two things being multiplied by each other, this x and the x minus 9. So we set both of those things equal to 0. X equals 0, x minus 9 equals 0. Well, this one's already solved, and this one we just have to add 9, so we get x is equal to 9. So we get the two solutions of x is equal to 0 or 9. And that's it for that one. Let's look at letter C. We get x squared minus 3x minus 28 equals 0. So in this one, we're going to use that sum and product method because our a value is 1. If you look, there is no GCF, and it's definitely not a difference of squares. So we're going to use our sum and product method, where we want to get a sum of negative 3 and a product of negative 28. Now from here, you got to think about what numbers give us negative 28. You got 1 and 28, 2 and 14, 3 doesn't go into it, 4 and 7. And I think that's it in terms of numbers that make 28. So now we just have to see which one would give me a sum of negative 3. Since I want a negative 3, the larger number has to be negative. 1 and negative 28, that's negative 27. Not going to work. 2 and negative 14, that's negative 12. Also not going to work. 4 and negative 7, that does give me negative 3. So 4 and negative 7 are my factors. So we get x plus 4 and x minus 7, and that's going to equal that 0. Now from here, we need to set each factor equal to 0 and solve each equation. So we get x is equal to negative 4 and x is equal to 7. And then we just put them both together in a final solution set of negative 4 and 7. And that's our answer. So think about it, if we took either one of these numbers and put it back into this equation, we should get an answer of 0. If you want to, pause and check and see, make sure that works. So let's move on now to example D. Now this one, is there a GCF? I have an 81 and 100. There is no common factor there. but it is two terms, and 81, x squared, and 100 are all perfect squares, and they're being subtracted. So this is a difference of squares. So all we have to do, difference of squares, is take the square root of this, which is 9x, take the square root of 100, which is 10, make another set, 9x and 10, then we make 1 plus, 1 a minus, and we set it equal to 0. So to solve this, we set each of those individual factors equal to 0. So 9x plus 10 equals 0, and 9x minus 10 equals 0. Then we solve. Subtract the 10. This equals negative 10, divide by 9. We get negative 10 ninths. Same thing here, we're going to do the same work, and we end up with the answer of positive 10 ninths, because instead of subtracting the 10, we had to add the 10. So our two solutions are x is the set of numbers negative 10 ninths or positive 10 ninths. That's it. Okay, let's go down here to the next few examples. So example E, this one's a little different. Take a second, see if you can figure out what's different about this problem. So if you noticed that it's not equal to 0, you figured out what was different about it. So what we have to do to solve any quadratic is first make sure it actually equals 0. Because you can't use that zero product property if it doesn't equal 0. So what we're going to do is we're going to add 72 to both sides. We're going to add 72 to both sides to make it equal to 0 on the one side. So we end up with 2x squared minus 24x plus 72 equals 0. So now we can start to factor since the one side is equal to 0. And if we look, all of these numbers are divisible by 2, so we can factor out that 2. So we get 2 times the quantity of x squared minus 12x plus 36, just dividing 2 out from each of those terms there. And that's going to equal 0 again. And then this 2 we can divide out, and then we're just left with x squared minus 12x plus 36 equals 0. Then we can factor, and because our a value is 1 now, we can just use a sum and a product. And our sum needs to be negative 12, our product needs to be 36. So think about the ways you can get 36. There's a few different ways. You can do 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5, 6 and 6, and I think that's all. So if we look, the only one that would also give me a 12, that one, is negative 6 and negative 6. So that is our factor pair. So we get x minus 6 times x minus 6 is equal to 0. And then we solve this. Since they're both the same, we can just solve one of them, x minus 16, x minus 6 equals 0. We get x is equal to 6. And that is our solution there. Okay, interesting one. Let's take a look at another one. Letter F, 3x squared minus 8x plus 4. Alright, so this one is set equal to 0, so we're good there. It doesn't have any GCF, and it's not a difference of squares. But the a value is greater than 1, so this one, we're going to have to do the slide and divide. So to start, we have to get a sum of negative 8, but we have to slide 3 times 4, get a product of 12. So think about the ways to get a positive 12, multiplying and adding to get a negative 8. So what comes to mind is a negative 2 and a negative 6. Those together would give me positive 12 and add to give me negative 8. So those are my factor pairs. X minus 2 and x minus 6 equals 0. But we had to multiply by 3 to get that 12. So what we have to do is divide out that 3 from each of those. Now when we do that, this 2/3 doesn't work out, so we bring up that multiply or the dividing term into the front of x. We get 3x minus 2 And on this one, 6 divided by 3, that is 2, so we get x minus 2 equals 0. Now from here, we still just set each factor pair, or each factor equal to 0. We get 3x minus 2 equals 0, x minus 2 equals 0. And then we just solve from there. This one, add 2 to both sides, and then divide by 3. And on this one, we're going to add 2 to both sides, and we'll get 2. So our solution set is x can be equal to 2/3 or 2. And both of those solutions would work if we substitute them back into this original equation here. Okay, a couple more examples to look at here. Almost done. Alright, so G, example G here, again not set equal to 0, so we got to get this equation equal to 0. What I would do is get the 6x and the 16 to this side of the equation, so minus 6x minus 16, and we simplify this, that side equals 0. I'm going to make this side 0, but same idea. And then we'll get x squared minus 6x minus 7, because 9 minus 16 is negative 7. Now from here, we can factor this, and it's just a straight up sum and product problem. Sum and product. We have negative 6 for our sum, and negative 7 for our product. The only way to get 7 is 1 and 7. If I want a negative 6, 7 has to be negative. So my two factor pairs are x plus 1 and x minus 7 is equal to 0. And then we set those both equal to 0. And we solve, so we get x is equal to negative 1 and x is equal to positive 7. So our solution set is negative 1 and 7. And that's it for that one. So, little extra step here in the beginning to get set equal to 0, but once we did that, pretty straightforward problem. Letter H. This one, right off the bat, I see a GCF of 5. So I'm going to divide that out. What I'm left with is x squared plus 4x plus 4 equals 0. And if I divide both sides by 5, I'm left with x squared plus 4x plus 4 equals 0. And then I can do a quick sum and product here. So I have a sum of 4 and a product of 4. So that's going to be 2 and 2 to get a product of 4 and a sum of 4. So that's x plus 2 and x plus 2 equals 0. So to solve this, since they're both the same, I can just set one equal to 0. They have the same solution. So my solution set is x is equal to negative 2. And that's it. If I substitute that into the equation, I will get a 0. Letter I. This one, right off the bat, notice that 15 and 10 x, they both have an x term and they both have a 5 in them. So first off, I'm going to try to get rid of that GCF. I'm going to divide out that 5x that they both have. And then what I'm left with is a 3x minus 2. That's going to equal 0. Now if you look, I have two factors, neither of which have an x squared. And so basically all I have to do now is set each of those factors equal to 0. 5x has to equal 0. 3x minus 2 has to equal 0. And then I just solve. This one I divide both sides by 5. I'm left with x is equal to 0. And this side I'm going to add 2. And divide by 3. And I get x is equal to 2/3. So my solutions are 0 and 2/3. That's it for that one. And then finally our last one here. And this one looks like there should be a GCF, but 18, 25, and 3 do not have a greatest common factor. So because my a value is greater than 1, this is going to be a slide and divide product. So we start out with a sum and product. Our sum needs to be 25. Our product needs to be 18 times 3, our slide there. So then 18 times 3 is 54, and because that 3 is negative, it's going to be negative 54. So we have to think about what numbers multiply to give us 54. Well, there's 1 and 54. And if I want it to be negative, let's make that smaller number negative. It's going to be a sum of 53, so that won't work. Let's try 2. Negative 2 and 27. Well, that will give me the sum of 25. So those are my two factors, x plus 2 and x plus 27. Now the problem is, though, I had to slide and multiply by that 18. So what I need to do now is divide each of those by that 18. So now that I did that, what I have to do, 2 doesn't go into 18, but it does simplify a little bit. So it's going to become x minus 1 over 9. And this one, same thing. Oops, erase that there. 27 over 18 doesn't completely simplify, but it doesn't divide evenly, but it does simplify. So this is going to be 3 over 2 if you divide both by 9. And now I don't want these fractions here, so what I'm going to do is divide by 9, I'm going to multiply by 9, and it's going to give me 9x minus 1. And this I'm going to multiply by 2, and that's going to give me 2x plus 3. 0. Now I can just set each of those equal to 0, and I get 9x minus 1 equals 0, and 2x plus 3 equals 0. Now I just solve these two individual equations. Add 1, divide by 9, x is 1 9. And this I'm going to subtract 3, and divide by 2. X is negative 3/2. Okay? So, with that in mind, those are my two solutions. X is equal to negative 3/2 and 1 9. And that's it. Last problem in the example set. Fantastic work. If you want to, feel free to rewind, catch a different problem one more time. And please, please, please remember, we are here to answer questions, so feel free to message your teacher and ask a question if you have any. Practice on this is going to be, let's see here, page 12 in the packet.